Hello, in this video I'm going to explain my thought process while I was solving or while I was proving this trig identity during the trig classathon. So this is the identity I got. Now for the sake of this video, I'm going to change this symbol to theta because I'm more comfortable using theta, but it's going to be the same question, just this is what I got during the trig classathon. But for the sake of this explanation, I'm going to change the symbol to theta. It's just a different symbol, and I'm just more used to writing theta. So I'm just changing this to theta. Okay, so now I changed everything to theta. Now, when I was trying to prove this identity, I was thinking, okay, first thing you do, you always start off by simplifying the more complex side. So in this case, that's the left side. Now, keep in mind, secant is the same thing as saying 1 over cos. Cos is the reciprocal of secant. So, when I simplify the left side, I want to try to think of trying to eliminate all the signs in the left side so that I can make it equal to this side. Because this is the same thing as 1 over cos. So, while I simplify the left side, I want to keep that in mind that I'm trying to get rid of these signs, or the sign functions, okay? When I was solving this identity, or proving the identity, I noticed in this step I couldn't really use a fundamental identity. It doesn't make sense to use any identity. So what does make sense is to add these two expressions by obtaining a common denominator. So in this case, the common denominator would be 1 plus sine theta times cos theta, right? So if we're multiplying this by cos theta, we have to multiply the numerator by cos theta. And if we're multiplying this by 1 plus sine theta, we have to multiply this by 1 plus sine theta. Okay, so first off, I do put ls here for left side to show that I'm working with the left side of this equation. So now what I did was I obtained a common denominator by multiplying these two together. And since I'm multiplying this by cos theta, I multiply the numerator by cos theta, right? And over here, since I'm multiplying this cos theta by 1 plus sine theta to get a common denominator, I multiply the top by 1 plus sine theta as well. Okay, so now what I did was I basically just simplified the numerator. So cos theta times cos theta is just cos squared, or cos theta squared. And when you distribute this term to this bracket, right, 1 times 1 is just 1. 1 times sine theta is just sine theta. Sine theta times 1 is sine theta. Sine theta plus sine theta is just 2 sine theta. And then sine theta times sine theta is just sine squared, or sine theta squared. So now that we simplified the numerators, all we have to do now is we just have to add the numerators because the denominators are the same now. Okay, so now all I did was the expression we got down here, I just moved that up here. So we had cos squared theta over 1 plus sine theta times cos theta plus 1 plus 2 sine theta plus sine squared theta over 1 plus sine theta times cos theta. Okay, I just moved that expression up to here, and now you can just add the numerators, right? Because it's just basically a fraction now where the denominators are the same. So when you add the numerators, you just get cos squared theta plus 1 plus 2 sine theta plus sine squared theta over this denominator because it's the common denominator. So now that we've added, right, the numerators, now you want to think, or now when I was solving this question, I was trying to think, how can I get rid of a sine function? Because I want to get rid of the sine because this is secant, right? And this is the same thing as 1 over cosine. So, cos I want to keep. I'm not going to touch that, okay? 1 plus 2 sine theta, I can't really do too much about that because no trig identity completely eliminates the sine with the 2 sine theta, right? But notice how sine squared theta, right? Notice how we can actually get rid of the sine squared theta by using the Pythagorean identity. That's the Pythagorean identity. So notice how sine squared theta, that's the same thing as saying sine squared theta. And then if we bring this cos squared theta to the other side, by subtracting cos squared theta on both sides, you get 1 minus cos squared theta, right? This is what you get. So 1 minus cos squared theta is the same thing as saying sine squared theta because of this identity. So we can actually change this to 1 minus cos squared theta. And notice how when we do that, we get rid of one of the sine functions. And that's what we want to do because this is secant. So that's what I did on during the classiphone, the trig classiphone. I erased this, or in the next step I wrote 1 minus cos squared theta. Okay? And you actually don't need the brackets. I was just putting the brackets there to show you how we're changing this from this, but you don't need to put the brackets here. Okay? So now that we've gotten rid of the sine function, or one of the sine functions, notice how cos squared theta minus cos squared theta, that just cancels out. So we can rewrite this now. We can rewrite this as 1 plus 2 sine theta plus 1 over 1 plus sine theta times cos theta, because the cos squared thetas cancel each other out, because cos squared theta minus cos squared theta is just 0. Okay, so now what I've done was, this is what I got down here, and I erased everything because I needed more space to write. So I just moved the expression that I had down here to here, and I erased everything. So now what you want to do is, you want to try to simplify everything still. So notice how you can simplify the ones, right? Because 1 plus 1 is just 2. Okay, so now this is where it can get a little bit tricky. So there isn't really any fundamental identity that we can use to get rid of the sine theta. It doesn't seem like we can really simplify this any further. I mean, it makes no sense to distribute the cos theta to 1 plus sine theta, because you're trying to get rid of the sine theta to make it equal this side. So you have to think, how can I get rid of the sine theta? Now, notice how in the numerator, this is where you have to factor. So now when I was solving this question, I was really confused at this point, and it took me a while to figure it out that I can actually get rid of the sine thetas if I factor the numerator, because if you factor a 2 in the numerator, you get 2 times 1 plus sine theta, right? And because, look, when you factor out a 2 from the 2, that's just 1. And when you factor out a 2 from the 2 sine theta, you just get sine theta, right? And notice how, now that you factored out a 2, the 1 plus sine theta, they just cancel out. And you get rid of the sine theta by doing that. So all I had to do was, when I figured out I could factor a 2 out, this question became a lot more simple. So now what you can do is, you can actually just cancel out the 1 plus sine theta, because they just divide each other, they cancel each other out. And now you're left with 2 over cos theta. Okay? And now, we can't simplify this any further, but notice how, if we look at the right side now, we have 2 secant theta. So if we bring this down here, you know from grade 11, secant is the same thing as 1 over cos. So in this case, secant theta is equal to 1 over cos theta. So we can rewrite this, we also have to bring down the 2. We can rewrite this as saying 2 times 1 over cos theta. Because 1 over cos theta is equal to secant theta, right? And now when you multiply the 2 by the 1 over cos theta, you know how 2 is the same thing as over 1. When you're multiplying fractions, you just multiply the numerators and the denominators. So when you multiply these two, you get 2 times 1 is just 2. And cos theta times 1 is just cos theta. Okay, and notice how 2 cos theta is what we got here, and 2 cos theta is what we got here. So we proved this trigonometric identity. So therefore, you can say when you prove that both sides are equal to each other, you can say left side's equal to right side, and then if you want, you can write out this whole thing again and put that below that. I'm not going to because I don't have enough room, but this is how I proved the trigonometric identity. So I was just trying, the point of this video was to just explain what I was thinking when I was trying to solve or prove this identity during the trig class-a-thon. Right, so just to recap quickly, I started by simplifying the more complex side, which is the left side. I added the expressions by obtaining a common denominator, right? Then I used the Pythagorean identity to get rid of one of the sine functions. I simplified the numerator. I factored out a 2 in this step, you can see, so that I could cancel out 1 plus sine theta. And I got 2 over cos theta, right? And then I proved that the right side is equal to 2 over cos theta as well. So that's what I was thinking when I was solving the identity, and I was just explaining my steps here.